Hey, boys and girls, welcome back to Fractions. We are on lesson 10.7. And before you look at your book, put your pencils down. Pretend I am working at the whiteboard. And I want to show you, this is a little bit of review, but also as an introduction to the page. Okay, so let's say I have a brownie pan, right? And how many squares, let's see if this is all brownies. How many squares do I have? Can you see them? Okay, 1, 2, 3, 4, 5, 6, 7, 8. So I baked 8 brownies. Let's say I have a friend who ate 2/8 of my brownie pan. Okay, he ate 2/8 of my brownie pan. How many brownies did he eat? He ate 2, but he didn't eat 2 whole pans. He ate 2/8. Okay, and then I have another friend who I gave another brownie to, and they ate 1 piece of brownie. How many did they eat? They ate 1/8. So did they eat 1 whole pan? No, they ate 1/8. So all together, we're adding fractions right now. All together, how many eighths did they eat? 1, 2, 3. 2 plus 1 is 3. Is that just 3? Did they eat 3 whole pans? Nope, they ate 3 fractions of the pan. So they ate 3/8. E-I-G-H-T-H-S. Eighths. Now, what does that look like as a fraction? 1/8 plus 2/8 equals 3/8. How many did they eat all together? 3/8. Okay, we're going to try that again. I'm going to go back and start with a new bunch of friends who ate brownies. Dun, 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 dun. Okay, so let's look back at our brownie pan. We still have 8s right now, right? And let me switch this. 8s. Okay, follow along with me. So now I have some other hungrier friends. This time I'm going to share with Isaac and Abigail. Abigail ate 2 brownies out of 8. So how many as a fraction did she eat? She ate 2/8. These are much smaller brownies. So she ate 2/8. Now Isaac was really hungry. He had Taekwondo and he's like famished. So he ate 5/8. 1, 2, 3, 4, 5/8. How many eighths did they eat all together? 2 plus 5 is 7. Is that just 7 brownies? It's 7 brownies, but is it 7 brownie pans? Nope. It's 7/8 of my brownie. What does that look like as a fraction? 7/8. Now let's work backwards and see if we can figure this out. 2/8 plus the 5/8 that Isaac ate equals 7/8. What did you notice, boys and girls, about the denominator? Did it change? Did the number in my brownie pan change? No, not at all. It's still out of 8 slices, 8 cuts of brownie. What is the only thing we added to get our answer? We just added the numerator. How many Abigail ate plus how many Isaac ate, and we got 7. So when you're adding fractions, only add the numerator. Only add the numerator. So once you get this, boys and girls, you are going to love adding fractions because it's super easy. You're just adding the top number. So the numerator is the top number, right? Okay, so now open your books. We are on page 289, lesson 7.1. Isaac, how do I make this full screen again? This view. Thank you, sir. Isaac's so helpful. He's my tech genius. Okay, so we are on page 289. Let's see what it says. By noon, 3/8 of a pack of dingoes, that's these guys right here, found a stream of water to drink from right here. By evening, another 4/8 of the pack found water. All together is a sign that's a clue word that tells us we're going to add. All together, what part of the pack found water to drink? So how many do we know? Just like our brownie, how many do we know are in the pack? What's the whole? In our fraction, what's the whole? In both of these fractions, the pack is made of 8 because you see right here, the denominator, that's how many are in the dingo pack. Now let's look what they did as an example here. So we have 3, 1, 2, 3 that came to drink first, 3 out of 8. See, this whole thing is 8. This is the entire pack of 8. 1, 2, 3, 4, 5, 6, 7, 8. So then we have the 3 that came first, and then another 4/8, 1, 2, 3, 4. So we have 3/8 plus 4/8, and then they show you right here, 3 plus 3/8 plus 4/8. Remember, we only add the numerator. 3/8 plus 4/8 equals 7/8. So 3 plus 4 is 7. Does the pack number stay the same? Is there still that many in their family? Yes, it's still 8. This does not change. The denominator does not change. It's wonderful and super easy, boys and girls. You'll love it. To add fractions with the same denominators, just add the numerator. That's what we've been doing. The denominator stays the same. I'm going to switch colors so we're not so brown anymore. The denominator stays the same. Hooray! Easy. Just don't forget. So let's look at this next one. I bet you can do this. 2 nights plus 6 nights equals what? 1, 2, 2 nights. And we know that this is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And then plus another 6 nights. 1, 2, 3, 4, 5, 6. What is that when we add them together? 2 plus 6 is 8. There is 8 total here. So, and we see it again. 2 nights plus 6 nights equals 8 nights. Do you see it? And the denominator stays the same. All right, let's move on. Are you seeing a pattern here? I bet you want to zip ahead of me, but try and stay with me. All right, let's look at it in our pictures. It says add the numerators. Write the denominator because it stays the same. Shade the model. If you don't shade the model, boys and girls, you got it wrong. I'm going to pick yellow because it's my favorite, in case you're wondering. So let's just shade it in 3 twelfths. These are all twelfths. 2, 3. Then I'm going to shade in another 4. 1, 2, 3, 4. And I should get my answer. I'm going to show you with orange so you can see it. 1, 2, 3, 4, 5, 6, 7. Let's see if that matches our equation. 3 twelfths plus 4 twelfths. 3 plus 4 equals 7. And what do we put on the bottom? We just write the denominator. It's the same. Hooray! All right, let's do another one. I'm going to color it in with yellow, and then I'm going to count it with a different color. Okay, 2. This is a bigger brownie pan. There's 18 cuts. 2, 1, 2, plus 7. 1, 2, 3, 4, 5, 6, 7. Sorry, I didn't count. 1, 2, 3, 4, 5, 6, 7, and then 2 more. 1, 2. Great. So how many did we get? 1, 2, 3. Let's do it right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if this matches. 2 in the numerator plus 7 in the numerator equals 9 in the numerator. And the denominator stays the same. Excellent. Okay, this time I'm going to do yellow again. Let's look at it again. 5. This is out of 10. Do you see? There's a brownie pan of 10. 5 tenths. 1, 2, 3, 4, 5. Plus another 2. 1, 2. How many do we have? I'm going to count it in green this time. 1, 2, 3, 4, 5, 6, 7. Let's see if that matches our equation. 5 plus 2 in the numerator is 7. Yay! And the denominator stays the same. Excellent. So we have 7/10, and that matches our picture. Okay, boys and girls, you should be able to do this. I want you to pause the video, and I want you to do these all on your own, and then I want you to come back and check with me. All right, so pause the video right now. And then when the video is done, when you are done with number 18, I want you to come back and look at these answers. Are you ready? And then I will explain them again. Super easy. 3 plus 4 is 7. Denominator stays the same. It's 8. 5 plus 1, 6. Denominator is 9 because the denominator stays the same. All right, 8 plus 3 is 11. I write 12 in the denominator because the denominator stays the same. All right, 8 plus 2 is 10. 18 in the denominator because the denominator stays the same. Do you see an awesome trend here that makes this so easy, boys and girls? 6 plus 2 is 8 in the numerator. 10 in the denominator because it stays the same. Excellent. 7 plus 2 is 9. The 11 is in the denominator because denominator stays the same. 10 plus 3, 13. 15 in the denominator because denominator stays the same. 11 plus 3, 14. 20 in the denominator because denominator stays the same. All right, please don't forget that. 9 plus 3, 3 plus 9, same thing. 12. 14 is in the denominator because denominator stays the same. Okay, add the numerators in number 13. 4 plus 10, 14. Denominator is 15 because denominator stays the same. Okay, can you add this in your head? I can. Here's how we do it. Number 14. 14 and one more is 15 plus another 10 is 25. And in the denominator is 30 because the denominator stays the same. You're only adding the numerators. Let's look at this one. 7 plus 8 is 15. And the denominator is 19 because denominator stays the same. Don't forget. 7 plus 3 is 10 in the numerator. Denominator's still 12 because it stays the same. You got it. 4 plus 1, 5. Denominator is 6 because the denominator stays the same. Excellent. Okay, number 25. Sorry, I scooted that up for you. Number 25. 7 plus 14. 14 and 7 more is 21. See if I can fit this on here. Oops. I will have to scoot this up a little bit. 21. And the denominator is 25 because you got it. The denominator stays the same. Excellent. Okay, boys and girls, we're almost done. This is like a really fast page. Hooray for everybody. I'm switching colors because I feel like it. There were 50 solar cars, and that is a car that's powered with solar energy. And the solar energy is from the sun. Excellent. 50 solar cars in a race across the Australian outback. 15 cars, look, they tried to sneak in the word instead of actually putting in the numbers. 15 cars were, since I can use colors, I'm going to do this. 15 cars were red. 27 cars were yellow. And I'll even do this. 15 cars were red. And watch this. I'm going to, never mind. 15 cars were red, and the rest were blue. Does it tell us how many the rest are? Nope. But we know that the rest are blue. What fraction, this is what we actually want to find out, what fraction of the cars were red or yellow? Does it want to know how many cars? No. What fraction of the cars? So if you give me just the numerator and think that's your answer, you've gotten it wrong. So we have 50 solar cars. That's the total number of cars. So where, boys and girls, oh, bless you. Thanks. Where does the 50 go? That's the total cars. The numerator's the part, the denominator's the whole. The fractions are parts of the whole. So denominator is the whole. So this whole number is going to be here no matter what. I'm going to show my work over here. So we have 50, right? And then how many cars were red? I'm going to even do this and switch it back and forth so you can see it. How many cars were red? 15. Okay. Denominator still the same. Plus, how many cars were yellow? That is 27. Hope you can see that. Then we have the rest were blue. Do we even need to know that? Honestly, boys and girls, is it asking how much were blue? Nope. Is it asking how much the rest is? Nope. So what fraction, could we figure that out? Yes, we could. But we don't have to. They just want to know how much this is. That's all they want to know. So all we have to do is put an equal sign right there. 15 plus 27, and I'm going to make sure I know how I'm doing this right. 15 plus 27. Sometimes I like mental math, and sometimes I like to double check. So 7 plus 5 is 12. Carry the 1. Don't forget to carry, my friends. 42. Ooh, I write 42 here, right? 42 cars. No, boys and girls. What fraction of the cars? Yikes, Mrs. Kornthal. Even though you told me, I almost wrote that down. That's not it. The answer is 42. And to make that a fraction, 42, that's the part, over the total number of cars, that's the whole. So 42, and the way, it's kind of wonky on this line, just write it like this. 42 50ths were, the label word, 42 50ths were, that's hard, red, yellow cars. Okay, awesome. Which are congruent figures? Boys and girls, this is review. So normally I don't do it with you, but I just want to color for fun, so I'm just going to do it. Which ones are congruent? Congruent is exactly the same. Exactly the same. So which one is exactly the same as this? This one. Exactly the same. Which one is exactly the same as this one? Exactly the same. Right here. Okay, exactly the same. Oh, they tried to trick us. Now remember, we can flip it, we could slide it, we could rotate it, but which one is exactly the same? You might be tempted to put this one because it's pointing in the right direction, but it has to be the exact same shape and the exact same size. So the only one that matches is this one. Don't be fooled. Double check your work, change it if you need to. All right, love you, love God, and love your neighbor. Talk to you later.